Okay, here's what's going on with graphing two variable systems. What they're talking about here is that you're going to have two functions, one right here and one right here, and you're going to graph them both and see where the lines cross, and where the lines cross will be the answer that you're looking for, okay? And so I think you've done some graphing before, but let's take a look at the first one. It says Rn equals 20n. So I'm going to graph that. I have R of n equals 20n. There's two things that I need to pay attention to when I'm graphing this. The first is where does the line cross the y-axis, and that is the number that's on the end here. And since there is no number on the end here, it's 20n plus 0, that means it's going to cross the y-axis at 0. This number right here, then the number in front of the end, tells you what the slope is. And since that's 20, that means we're going up 20 and over 1. And so what I'm going to do is change my scale here a little bit so that I can do that more easily. So I'm going to make this go, well, I don't know, look something like that. And so since I'm starting here at 0, 0, to find my next point, I need to go up 20. I need to go up 20 and then over 1 and put a point there. And then from that point, I need to go up another 20 and over 1 and put a point there. And when I connect those points that I just graphed, then that is the graph of this equation, R of n equals 20 times n. So now I need to take a look at the other equation, this one right here, which says C of n equals 5n plus 6,000. And so that's not really very nice at all because of the 6,000. Let's write that right here. C of n equals 5n plus 6,000, because what that means is this graph is going to cross the y-axis at 6,000, and so I don't even know if I can fit that on here. I need to get this to be, oh, there we go, scale that looks something like that, all the way to 6,000. So I'm going to put a dot at the 6,000 on the y-axis, and then this has a slope of 5, up 5 over 1, but since I'm going by 500s there, I'm going to probably want to change this to match a little bit closer to that. So let me make this scale bigger also. So now each square is 500. So from this point I would go up 5 and over 1, but I've begun my graph then. So from here instead I'm going to go down 5, 1, 2, 3, 4, 5, and over 1. And down 1, 2, 3, 4, 5, and over 1. And so what you're trying to do is figure out where these two graphs cross. And that's going to be way up there somewhere. So this problem is sort of a pain for us to do. So let's take a look at the next one. That one wasn't really so great. So let me get another page going here, and let's see what else they want us to do for the next one. So you can see in their graph, this is what they came up with for this graph here. This is the point where those two lines would cross. And so that's the answer to the question, is 408,000, but we didn't have room to show that on the graph. So let's find an easier one here. So this one says, the owner of a bike shop sells unicycles and bicycles, keeping inventory by counting seats and wheels. One day she counts 18 seats and 28 wheels. How many of each type of cycle are there? And so what they're going to do is try to so they're going to try and come up with a couple of equations that we can use here in this graph. And so the first thing that they know is the number of bicycles plus the number of unicycles is 18. And the reason that they got that is because each unicycle and each bicycle have one seat. And so the number of seats has to add up to 18 altogether. Then the other thing that they know, since bicycles have two wheels, and unicycles have one, is that their wheels are going to add all together to be 28 wheels altogether. And so that gives us a couple of equations that we're going to use to graph. The first one is bicycles plus unicycles equals 18, because like we said, there's 18 seats, so you have 18 of them all together. The second one is based on the number of wheels they have. Since each bicycle has 2 wheels and each unicycle has 1, and you've got 28 wheels altogether, that's what you have to have for that equation. 2 times the bicycles plus the unicycles equals 28. So those are the equations that we are going to graph. And it looks like their thing isn't coming through, so we'll do that on my board. So I need to graph b plus u equals 18. So let me write that down over here. B plus u equals 18. And then the other one that we had was 2b plus u equals 28. And so what we're going to do is we're going to pretend the u is the y. Okay? So I'm going to solve this for u by subtracting b from both sides. If I take b plus u equals 18 and subtract b from both sides, then that tells me that u equals 18 minus b. Same thing here, I'm going to take this and solve it for u by subtracting 2b from both sides. So those cancel, and that's going to give me the equation u equals 28 minus 2b. And so now I can graph those just like I did with the other problem. And this one's going to work out a little bit nicer because the numbers aren't quite so crazy. This one, the first one, like I said before, is going to cross the y-axis right here at this number that's all by itself. And in this case, that's at 18. So I'm going to put a dot at 18. And then the slope is the number in front of the variable. So since it says negative b, that means the slope is negative 1. So from here I need to go down 1 and over 1 and put a dot. Then down 1 and over 1 and put a dot. And if I connect those dots, then that is the graph for that equation right there. This one right here crosses the y-axis at 28 because that's the number that's all by itself. So I'm going to put a dot at 28, and it has a slope of negative 2. So from there I need to go down 2 over 1, down 2 over 1, and if I connect those dots, then that is the graph of that equation. And what we're looking for a solution is where those two graphs cross, which is right here. So the coordinates of the point there is 10 and 8. And so that means for this to work, I must have 10 bicycles, let's go bicycles, 10 bicycles and 8 unicycles all together. And that's because we let the unicycles be the y, so that's the second number here, and the bicycles were the x, that's the first number there. So that's the basic idea. I'm guessing they just have a couple more. Okay, so they're going to walk you through the problem here, what we just did, although I can't see that. Let's see what else we got going. Oh, okay. Then you need to understand that depending on how the lines are graphed, you could have some different answers come up. If they cross once, which is what happened in the last two examples that we did, since they cross once, that means there's one solution to the problem. If they don't cross at all, in other words, if they're parallel, then since they don't cross, that means there's no solutions to the problem. And if they actually come out to be the same line right on top of each other, that means that there will be infinitely many solutions to that problem. So there's 3 different situations that you can have from these things. So I'm just going to show you an example, I guess, of the different ones. For some reason that's not coming through on my deal here. Okay, so here's an example of infinitely many solutions because the lines are right on top of each other. Okay, and that looks like the same thing over again, so maybe that's all we need. Oh, all right, so let's take a look at this. It says, enter the ordered pair that is a solution to the system of equations shown in graph below. And so what you're looking for is where these two lines cross. And so since I have to go over 1, so if I start at 0, if I start at the origin, I have to go over 1 and up 3 to get to that point. that means that the solution of that system is 1, 3, and I won't enter that in, but you could if you wanted to. For this one right here, same deal. Where do these two lines cross? That's your solution. So if I start at the origin, I have to go over 1 again, this time up 2. So my solution would be 1, 2. Okay? All right, then this one, you need to come up with the graphs on your own and then type in where they cross. So let's do that. Y equals 3x minus 30. So let's graph y equals 3x minus 30. Second here. Okay, so since it says y equals 3x minus 30, that means that it's going to cross the y-axis this time at negative 30. So I need to change the scale so that I can see negative 30 on my graph. There it is. So y equals 3x minus 30 means it crosses at negative 30. And then the slope is 3x, so it goes up 1, 2, 3, and over 1 to the next point. Up 1, 2, 3, and over 1. Oops, over 1 to the next point. Ignore that point right there. And if I connect those dots, then that gives me that line. Then the other line that I'm trying to graph is y equals 1/2 x plus 15. So that's going to cross the y-axis at positive 15. And then this has a slope of 1/2. So it's going to go up 1 over 2, up 1 over 2. And then I need to connect those points. Okay? And what I'm looking for is where those two lines cross. So I'm going to need to change this up again a little bit. So I can see, oh, the line's staying there. That's not going to work out. So I'm looking for where these lines cross, which is somewhere up here. So I can't see that on this graph, but that is what you're looking for to enter into this thing right here. Okay? And then there's another one here. Same deal, you would just graph these two lines. This number right here tells where they cross the y-axis. This number right here tells you what the slope is. So you would start graphing this one by putting a dot at 25 on the y-axis, and then from there going down 2 over 1, down 2 over 1. This one right here, you start by putting a dot at negative 5 on the y-axis, and then from there you go up 3 over 1, and so forth. No, there we go. Okay, so that is the main idea. Don't know really if that helped much at all. Hopefully it did a little bit. So I will post this and let me know if you need anything else.